All right, hello all, and welcome to Catching the Cloud. Excuse me. It's going to be one of hopefully many streams that we do here from the cloud curriculum at SANS. My name's Ryan Nicholson. Before we do our introductions, we're going to talk about what we're going to talk about today. Our major topic is going to be least privilege, specifically, and of course, your major cloud vendor environments. Because we found that while I'm the author of SEC 488 and we teach SEC 488 quite frequently, it's a very difficult concept to grasp, or at least how to implement least privilege in your major cloud environment. So I'm actually going to open it up with a question. I see some comments rolling in. Hello to everyone from all around the world. We've got Rydia, Iran, we've got Montreal, Canada, Sweden. So it's getting quite the global reach here. So my question is going to be, can anyone define what we mean by least privilege, and more specifically, least privilege in a cloud environment? So mull on that for a little bit. Think of a nice drawn out answer, and we'll come back to those responses after we introduce ourselves. So I'll start with me since I'm on camera right now. My name is Ryan Nicholson. I author and teach a few different SANS classes, predominantly the SEC 488 course. That's the Cloud Security Essentials course. That's the bulk of my day job, bulk of my work nowadays. Also author and teach the co-author, I should say, along with Sean McCullough, the SEC 541 course, the Cloud Security Monitoring and Threat Detection course, and also one of 3 authors for Cyber Defense Net Wars. Myself, Andy Lehman, and Max D. I can never remember how to pronounce his last name. I think it's DeWeert. But anyway, that's predominantly what I do nowadays. So I'll pass it off to our resident Azure expert during this discussion, at least, Simon Vernon.
Hi, everybody. So my name's Simon Vernon. I am head of R&D for SANS in EMEA. So I'm based in the UK. As Ryan said in his lovely introduction there, I'm one of the instructors for SEC 488. I'm also the author of the Jupiter Rockets ranges, which there's some offensive ranges, and there's a defensive one that's coming out later this year. So it's great to be here this afternoon for you all, and I can see we've got people coming in from all over the world as well. So yeah, hope you enjoy the session with us this afternoon, and we'll jump onto some least privilege chat shortly. I shall hand over to Serge.
Hey, everybody. My name is Serge Borso, and I'm in Denver, Colorado, United States. And I run a company here called SpiderSec. We do offensive security, penetration testing, cloud security, things like that. I'm also a certified instructor with SANS, teaching SEC 488, and an upcoming author for SEC 388, which is specifically going to be more of an introductory level course to cloud security, if you will. So definitely happy to be here and great to see you. So welcome, and let's get this thing rolling.
All right. Thank you, Simon. Thank you, Serge. So this is going to be relatively informal. We're going to be bouncing ideas and concepts off of each other as we go. And of course, any questions at all, because the audience is going to drive a lot of our discussion as well. So feel free to throw in comments, throw in questions. We'll get to them as we see them in real time. I'm not going to hold anything to the end or anything like that. I do have a demo in store as well once we get some of the fundamentals out of the way and discussion points underway to kind of round out the hour or however long we're going to be here. It's kind of up in the air. It's like I said, it's very, very informal. So I asked the question early on, how would you define least privilege? And I saw a few answers in here after all the hellos. Again, welcome everyone from all over the globe here. Sharat, apologize if I say your names wrong. If anyone's seen The Witcher on Netflix, fantastic show, by the way, a little violent. So definitely don't have the kids around when you watch it. They call him the Butcher. So I'm like the Witcher when it comes to names. So I just want to apologize in advance. So Sharat says just enough access rights. Totally agree. Again, I'll give my own definition, but that's very close to my definition. I'll ask Serge and Simon what they think. Jared also says each person or resource has access to only what it needs. That's a very good definition in my opinion. Now in a cloud environment, let's define, and again, I like how Jared put that, person or resource. So in a cloud environment, you're gonna have more than just humans accessing your cloud resources. You'll have like service accounts. For those that aren't familiar with service or programmatic accounts, those would be things like a web application that you're writing, for example. May need to reach into cloud storage to access image files or web content or what have you. Well, that's going to have an account associated with it, a service account. in that environment. Now, when you create accounts in your cloud environment, they can be given permissions. Every vendor handles it a little bit differently. Like AWS is wildly different than Azure. So each one of those will have policies or permission sets or role-based access control. Again, depends on the vendor and how they define this, but that will define what they can do in that environment. And all too often, we're being very over permissive, which means that that user account maybe never needs to talk to specific cloud services, yet they have the rights to do so anyway. So for me, least privilege will be minimize what permissions those accounts, whether they're human or non-human accounts, can do in your cloud environment. Only allow them to not only perform specific activities, but only perform those activities on the resources that they should have access to in that environment. Did I miss anything there, Serge or Simon? You want to jump in and expand
That's really
upon that,
it.
if you will?
That's really what it comes down to. I mean, the only other thing I'd throw in is the principle of least privilege, as in the least amount of privilege you actually need to get the job done. All right. And so that's kind of goes hand in hand with exactly what you said, but really just to kind of put a pin in that, just be like, we don't need to grant access permissions to the service account to this user, given their role, given the services they need to interact with, given what this machine is going to do with these permissions. And it's easy to say, oh, the least privilege, that's the way to do it. But actually getting to the point of how you define what is required for the proper functionality, that's when it gets a little more challenging and fun.
Well, you can take it one step further as well, because you don't have to be necessarily granted permissions for that particular, all the time for a particular role. You can take permissions as and when you need them to do or run specific tasks. So there can be a lot of instances where, for example, you may need the requirement to spin up some infrastructure or terminate something, but you don't need that permission all the time. So why have it all the time? There are capabilities inside, particularly in AWS, where you can assume an identity of another role or even another account to make those things happen. Again, protecting your resources and that least privilege motto.
Awesome stuff, Serge and Simon. Thank you. Now, again, this is easier said than done, right? It's easy to say, I'm going to have a user in my environment. This is these are the roles and responsibilities of this user, and this is exactly the minimum amount of privileges that this user will ever need. It's quite the hunt trying to figure out exactly what goes on behind the scenes, like what API calls are going to be made from that user system to the cloud environment. And that's where my demo will come in a bit later, kind of showing you how you can capture what activity is happening from a user so you can create that much better policy. But as Simon said, it's kind of in flux as well. So that adds another challenge. Does the vendor give you the ability to, at this given time, you can perform these actions, but during normal course of business, those actions are more restrictive in that certain situation. So, and as I said earlier, the vendors approach permissions and things quite a bit differently. They do provide you things that help you move in the right direction, like pre-existing policies and permission sets and things like that. Serge, would you want to talk about like AWS and what they provide the users, kind of like the out of the box experience with their IAM service, and how you can start working down the path of least privilege?
Sure. So when you go to, and I'll start really at like most basic level. When you go to create a new account within AWS, and depending if you're working for a company already, or for just like a personal trying out let's say you're going to start with the free tier in Amazon. So you go to log in and create your account. You're what we call the root user, as in you have the most permissions possible granted. So you have all the permissions in the world to do whatever you want, whether that's create new users, purchase new services, deploy across your infrastructure, as the case may be. Within that element, you guys start thinking about, well, how would I lock down this identity and access management component, this service, if you will? And of course, if it's just you, one person, you're thinking, okay, well, what's really the risk with this? You see that with single use servers and things like that as well, where it's like, I'm only a person using it, so how deeply should I lock this down? Which doesn't really scale well when we start talking about, well, I'm not just one person anymore. I'm working for a company. We have an organization. There's multiple users. How do we actually account for that? But I'll back it up and just think of start with something simple. One user, one person. How would you restrict access? And it's like, well, why do I want to restrict access? It's all for me. Well, the problem is when we put ourselves in a position where we're going to be potentially being attacked, which is, let's say we have some exposure, we have passwords sitting in a file somewhere, we're being attacked with social engineering attacks, or someone's trying to take advantage of us and trick us into divulging information, or even doing a webcast or something where we're sharing our screen, doing a YouTube video, and all of a sudden we're sharing our screen and we have some sensitive information being exposed because we didn't, think through that carefully. The point is there's attack surface. That's the terminology where we could potentially be targeted by an adversary, and we have to lock that down. So what do we do, right? That's really the question. One of the best things we can do is actually what we could call two-factor or multi-factor authentication, where instead of just logging in with a username and a password, we're now going to enforce a second factor. So not just something that you have, but something that or vice versa in this case, of course. So something username, password, that's in your brain, you know what that is. Something you have is more a token, soft token, hard token, Google Authenticator, something like that. That's one way you can help ensure that if your account is exposed to the web, to an adversary, to whatever, the adversary has to have more than one piece of information to compromise that account successfully. And that goes whether it's you testing the special little free trial or free tier of AWS, or your enterprise with thousands and thousands of users. Same concept applies across the whole spectrum. So that's probably one of the most important things you could do, other than lock away your root access or your root keys as well. And I'll stop there, but that's a fair way to kind of begin thinking about this. If we're going to be attacked, what would we want to do to help lock down our own accounts?
Thank you, Serge. Now I'm going to switch gears a little bit. Same question though to Simon. Like, what does Azure give you as it comes to options in that environment, kind of like out of the box? Like, what can you do as an Azure user to work towards least privilege, or at least, like Serge said, like put the I've been attacked hat on, or I currently have a breach in my environment? How can we limit what we refer to as the blast radius of an attacker in our environment, or minimize the risk of that infection happening in the first place? Kind of a lot of things thrown at you there, Simon, kind of all over the place. But like, what's all the answers in Azure is what I'm getting at.
What are all the things? The first thing we have to look at, especially with Azure, is the major differences in the way that Azure and AWS and GCP and all of the other different cloud providers operate. Particularly the difference between AWS and Azure, which are the two of the most popular and largest cloud platforms at the moment. As we just heard there, in IAM, we have the capability to lock down our root accounts. We have the ability to create roles and user profiles in order to grant access to the resources inside that account. Azure is completely different. Microsoft have been doing authorization and authentication for a long time, and they've transferred that information over into Azure. Whereas AWS, they kind of started making it up as they went along, sort of 10, 12 years ago. And so when you look back at Microsoft's way of doing things, you have an Active Directory. You have a root account, even though it's not called a root account, it's called a principal account, and it's the one that you open your subscription with. Once you open your subscription, you then delegate access to those subscriptions within your tenancy. But the way Azure is laid out is completely different from AWS. So in AWS, you have an account. In Azure, you have a tenancy and a subscription, and they are very different things. You can think about Azure in the way of it being a hotel. The tenancy is the entire hotel. So that is where your Active Directory, or where all your user accounts are stored. You do have some security groups, and you do have some roles and permissions stored in there. But when you delegate or create a subscription, all you're doing is creating a floor of your hotel. So you can have multiple subscriptions linked to a tenancy, each subscription being a completely individual floor with its own RBAC, or its own sort of IAM policies or roles or rights associated with it. And then inside those subscriptions, you have all of your particular assets or resource groups. And they're just, resource groups just being containers for assets inside the cloud. And you can delegate permissions to those resource groups and those assets. So you can carve down quite a large expanse of infrastructure into numerous resource groups, into different subscriptions, all within one tenancy. So the way that it works is completely different from AWS. And I highly recommend looking at from the get-go, if you've never experienced Azure before, is look at how the tenancy and the subscription model works and how permissions are applied across that board. because it's a rabbit hole and there's a lot to it.
Thank you, Simon. Yeah, that was a very good analogy. I'd heard that one before from Simon because we've taught the course before, but I love hearing it every time. It really helps make that Azure layout a little bit more clear because, like Simon said, it's quite different than how AWS, GCP, Oracle, IBM, whatever cloud vendor is. It's very, very Microsoft how they manage those things. So it's a little bit to wrap your head around. But once you do, and you're very well on your way for more segmentation and helps you with getting more towards that least privilege concept that we're talking about here, right? You have tenancies, you have subscriptions, you have resource groups within subscriptions, and then you finally have your resources. So you have multiple layers where you can apply those permissions. Like, let's say you have a web developer, right? And all the web developer resources are inside of one resource group, inside of a subscription, inside of a tenancy. You can apply the permissions at that resource group to only give access to anything inside that. They won't get access to anything else in the subscription, other resource groups, and so on. So lots of cool ways you can really think about your restrictions, but it does add to the complexity. So it's a lot to wrap your head around, even in your own environment. You might think you know it very well, but as things change, it's quite a bit to kind of keep track of there.
That's actually a really good point. I wanted to ask you something there while you're on that subject. Oh, here another question comes up. I was just wondering if all that complexity that both of you just really highlighted there, in your opinion, does that make the process of implementing least privilege more challenging?
I would say more challenging for sure, but more effective at the same time. So like anything that's worthwhile and effective, I would say for the most part, when it comes to security, is going to be tough to implement for sure and maintain in the long run. Simon, do you have anything to add to that?
Absolutely. I mean, the whole point of these tools is to utilize and leverage the capability of the cloud, which is elastic in nature, to the best fit for your particular organization or deployment. So I've just designed a new infrastructure for a social media application that has all of the customer-facing systems in a completely separate resource group from everything else that's used to manage that infrastructure. So the databases are in a different resource group from the web servers. The images that are derived, all of the web servers and the front-end systems and the proxies are all in a different resource group from everything else. So there's absolutely no access or communications back to anything that's related to management of infrastructure. I've just lost my camera. Sorry about that.
No, it's still there.
It's happened to the best of us. Yeah, and, we've all had blunders while teaching, I'm sure. Nothing worse than the camera being on and you not knowing it, or the mic being on and you not knowing it. But I've never seen a big crash like that, Simon. So thank you.
Yeah, that's my camera disappearing off the top of my computer.
Nice.
So it's all about utilizing the tools in the right way to get to the outcome that you want. The cloud gives us this availability to segregate that infrastructure, but it is complex. There are numerous facets to this that are not as easy to grasp as concepts as you'd think. But once you do get your head around it, the tools are awesome. They're really powerful.
Cool.
Yeah, and we're kind of going like extremely down a rabbit hole already, but and I was kind of leading the question earlier, like what do vendors give you? And we were explaining how vendors lay things out, what options are available. But one of them, if we're sticking to that least privilege, like if I want to go from everyone in my account has administrator access and I want to start tightening things down, I'll give AWS as an example here, because that's my strongest cloud vendor. They do have what are called managed policies, which you can just by simply reading their name, they give you a general idea of what permissions may be associated with this particular policy, as they call it in AWS, which if you attach that policy to your user instead of administrator access, they're much more restrictive. Now, for instance, I'm not going to use any one vendor here in this example, but let's say your day job for your particular user that you're looking at is they're doing like a lift and shift. They're moving systems from their on-premise environment, like virtual machines or physical machines, into the cloud environment. They want to deploy a Linux server, for example, in a virtual machines service. Well, they obviously do not need full administrator access to every single service in your chosen cloud vendor. So hopefully your cloud vendor will have those managed policies, managed permission sets. Managed meaning the vendor is maintaining those standardized permission sets. They might have one called like VM admin or virtual machine admin or contributor or something like that, where if we apply that to our user instead, they should be, in theory, restricted to just that virtual machine service. But as we find, if we dig a bit deeper into some of these policies, they actually get a little more permission than what you may think, because they got to build that policy generically, like to account for like anyone coming and deploying a virtual machine in that environment. Because in deploying a virtual machine, you might be modifying network settings, right, to allow SSH access to that Linux server so you can manage it. Well, if you can't influence the network settings because you can only work on that virtual machine service only and not touch, say, the VPC service or the virtual private cloud service, excuse me, then you're not going to be able to successfully deploy that system. So you see a little bit of what we call privilege creep in some of these policies, where they relax the permissions just so that folks can be more successful. And again, we find that in our own environments as well, because it's going to turn out that people need more and more permissions. But if we can be on top of that, or better yet, build our own custom policies in these cloud vendor environments, we can be much more restrictive. Because let's say our virtual machine deploying person doesn't need to modify network settings. They just have to reference them and say, I created a security group in AWS, or a networking team member did, right? Because they're controlling the networking access. I'm going to reference that. I don't need to create one. I just need to be able to see it and apply that to my virtual machine that I'm deploying, for instance, right? So that's something we can custom tailor for our environment. But again, it's challenging. It's very, very difficult to do. Again, my demo is not going to solve all your problems later, but that's going to show an approach that, say we have an infrastructure as code tool that deploys a bunch of stuff in our environment across multiple services. Well, we can look at a way to see what that tool is doing and build a policy specifically for that and say, the account that this tool uses, this is all you can do, nothing more. That way, if that credential is stolen, yeah, the attacker may be able to deploy things in our cloud environment. Yeah, they might be able to read sensitive resources, but they're not going to get access to absolutely everything in our environment. Okay, so I'll get off my soapbox now and see if Serge or Simon have something to add to that, or something totally different.
No, that's a really good point. And the way I think about that is principal least privilege. There's built-in groups and policy settings you can easily deploy or leverage within an AWS or Azure environment. Then thinking back to AWS specifically, what you end up with, just kind of Ryan's point, is the vendor's ultimate outcome. In this case, I'm speaking about AWS. Their ultimate solution is going to be, let's give you the amount of permissions we feel are going to be appropriate given this role within the environment. Got my quotes in here, with this role in the environment, right? So those may end up being extra permissive for our purposes. We may be, because AWS has to be at the point where they want things to just work out of the box. Like, you deploy your AWS environment, you say, hey, this role seems to be appropriate, check out the permissions. Yeah, that looks like it should work. You don't want to have, as a sysadmin within AWS, you don't have to keep on going back and saying, oh, well, this wasn't permissive enough, or this person's complaining you don't have the access they need to do their job. And then you go back and tweak, and it's like, well, this out of the box role didn't even work. So that's kind of pointless. And you end up having to go create your own one. So that's why you see that extra permissions, if you will, within some of those built-in roles. But I mean, it's fluid enough and flexible enough to where we can clearly create our own, custom roles if we choose to do so. And that's really what it comes down to a lot of the time, is just understanding who's doing what within the environment, and not only what that person says they need to do or they think they need to do given the role that they have, what they got hired to do, really. And it's like, okay, based on what their job description is, I think I'm going to give you these different permissions so you can perform your job. But keeping in mind, from a security perspective, what's the least amount of privilege required for them to do their job successfully? And then, of course, we tune it back and scale it back. But to Ryan's point, if we had some type of tool that could help and say, hey, this is actually what you're doing, this is how we can lock it down, this is what the permissions are going to be required for you to actually do your job, not what you think they are, but what they actually are, that could be super helpful.
I do like that point, and particularly about the cloud vendors providing you this tooling initially to create these capabilities, to create these default roles, but they leave them quite wide open. And it's that a waiting between, how many support requests are we going to get on this hand from people who are trying to build something in the cloud and are failing miserably because they can't get the permissions right, to actually overextending those permissions and being too permissive in those things. It's a really good question, and I'm assuming the cloud vendors have looked at this from an operational perspective and said, we have to delegate these times of rights out. This is why we create these sets of default rules. But then it should also raise questions to us as the security professionals who are implementing these infrastructures in these environments. That is, do we rely on using the default roles? Do we rely on the default that the cloud vendor has given us when they actually have a different operational requirement behind the scenes than what we use as the consumer? Brings me back to quite an interesting point that you made as well at the beginning about multi-factor authentication. Why don't they enforce multi-factor authentication on the root account by default? It's something that's left as an optional. In which case, is it optional? Should we ignore the fact that there's no multi-factor authentication on that from a user's perspective? Microsoft have gone completely the other way. They now have implemented where you can authenticate to your Azure account without a password. You can do it all via the app, and they still class that as multi-factor authentication. What defines multi-factor authentication? Something you have and something you know. Well, they're defining your user account as something you know. But is that still valid? And I'll open that question out to the board, because that's it's a toxic question. I've posted it on Twitter a few times. It's been quite an interesting response from people. There was a whole discussion about it with another SANS instructor on LinkedIn. It's a really interesting question.
And speaking of interesting questions, I saw a couple pop into the comments here from LinkedIn user. So someone on LinkedIn. So what are some best practices for least privilege? We will definitely be getting to that here. I'll give my 2 cents on it here in a moment, and a challenge that I faced in an Azure environment. So maybe Simon can tell me a better way of doing this, but it's actually part of the SEC 488 discussion that we have, a case study, if you will. So it's a double-sided question here. For doing it right in a new implementation, which is where I'll focus at least my discussion, and then for discovering and fixing an existing deployment. Fixing, I'm assuming, means got over permissive accounts. How do you restrict them down a little bit? Now, actually, I will address that first and foremost, because that'll tie into my my discussion here. But for discovering, so cloud vendors do give you typically good logging capabilities of management activity. We call that the management plane, or the control plane, if you will, of your cloud environment. So when people are making requests to your cloud vendor environment, they're doing so over API calls, application programming interface calls. Like, whether you know it or not, you're either doing it through your web browser, or you have a tool that's on your behalf, or an account's behalf, I should say, sending API requests to the vendor. And if you have the permissions to perform that API request, then the action is taken, whether it's download this data from a cloud storage environment, or turn off this virtual machine, or deploy this database, or what have you, right? And again, that's ultimately what we're trying to limit when we talk about least privilege, what API calls can be made by that user. But anyway, a lot of that's being logged by the vendor. Like AWS has CloudTrail, Azure has their activity log, and then Google has their cloud logging services as well. So that would be an excellent place to kind of see what your users are typically doing. It's a lot of analysis. Maybe you could create a tool for it. Maybe there's tools that I'm not aware of that can perform that analysis for you. Some vendors offer some solutions as well to say, like, here's what this user normally does. Here's a policy we recommend for this particular user. They don't need administrator access. They only perform these things on a regular basis. So it can be very manual, or it might be tool assisted, but that would be the approach I would take to fix an existing deployment, or an existing user, I should say, and their privileges. But what about, testing out, if I want to have this particular user be able to perform these actions, how do I know what those actions are in the first place to further restrict them? That's a bit challenging, because there are tens of thousands of different API calls that can be made in your major cloud provider environments. Can you know them all and what every one of them does? I haven't met that person yet. I mean, I write a course for SANS, and I'm going to be the first to admit that I don't know every single API call that every vendor has. I know some of the more common ones, of course, but we have to have a way to discover, if a user's trying to do a thing, what are the API calls? That way, that will influence our policies, our permissions, our roles, and so on in that environment. So I think Simon knows where I'm going with this because I'm not one to complain about cloud vendors. They've all got their problems. But when it comes to Azure and logging API calls, at least as compared to AWS, they don't log as much because the activity log service, that again is the management plane API call activity, only captures create, update, and delete events. So if you're familiar with CRUD, the R stands for read. That's what's missing. So if during my day job, I need to do something where I read, like say, hey, give me this storage object, or let me see what available network security groups I have, and so on, that's not being recorded in Azure. The reason why I bring that up is because if I'm trying to create some custom policy in Azure, which by the way, another pet peeve of mine, requires more money, higher subscription. I think you need Azure AD Premium for that. But anyway, if you have that in place, you have to, and let's say you want to test out deploying a virtual machine and you want to restrict that user so that they can only do that, you would consult the activity log. So when they deployed a virtual machine, or my test user deployed a virtual machine, collect all the events that happened, and then you can take those events and make that part of the role in the Azure environment. The problem is the read events are missing. So if you create that role based on what you see in the activity log, that user is going to have a bad time. They may not even be able to deploy the network, the virtual machine, because they can't read the network security group information, or they can't see what available resource groups there are, because those are read activities. So it's a lot of trial and error. So when you try to deploy something, it'll likely error out. You have to look at the error message in Azure, see why. I mean, they're very descriptive. They'll say things like, the user tried to perform this, or during the deployment, this activity was attempted and it was denied because it wasn't part of your role. So you add that in, you try again, probably fails again, and so on and so forth. I think when I tried to create that perfect least privileged user, at least in my mind, that could only deploy a VM, I think it was around a dozen or so failed attempts before I was finally able to deploy a virtual machine using very minimal rights in that environment. Right. So that's my take on those two questions. Again, it's been a while. So the two questions I'll toss back out to Serge and Simon, see if they have anything else, is what are some best practices for least privilege for doing it right in the new implementation, or discovering and fixing an existing deployment? Anything you guys would like to add?
I think you hit the nail pretty much on the head with regards to logging inside Azure. Yeah, by default, it's pretty limited, especially as you said on read. There is a solution to it, which is you can turn on a lot more security features, or you can turn on a lot more services inside Azure. But you are encroaching into using or landing in the space called log analytics. Log analytics starts increasing your subscription costs on a per machine, per network, per asset, per log consumed basis. And as you can imagine, that does increase the cost substantially. AWS is in far better shape when it comes to accessing those logs from a default position. Microsoft do seem to think that that smaller organizations or smaller vendors or smaller user bases aren't going to utilize their services quite so much. And this has happened throughout Microsoft's history. They're not particularly great with dealing with small businesses or smaller enterprises. And so the cost of this is quite prohibitive in some circumstances. But as we said, there are ways around it. There are extra ways you can get access to that data. So, I mean, in AWS, the logging is considerably better when it comes to viewing how operations are running, or what entity, as in person or resource, is requesting particular assets or looking at things. The one big difference, though, in Azure, there is one service that does actually log reads really well, and that is the Vault. And I know that because I've just spent spent most of Christmas actually building 2 vaults for an organization who were putting in log username and account rotations and things like that. And I was so happy when I found out that they do, by default, log reads. So.
Merry Christmas. Awesome. There's your present. The only other thing I would add, because it was covered quite well by Ryan and Simon, is baseline normalcy. That's really the next step, I think. Once you're understanding who's doing what inside the environment, what level of permission are adequate for what's actually being what actions are being performed, the next thing you really want to do is start thinking about, is this normal? What does that mean? Okay, what I mean by that is specifically the actions being performed by users and services and resources within the environment. Are we understanding what a normal day, week, month looks like for these requests that come through the API? And then trying to understand if this weird little blip on the radar from last week is indicative of, oh, we hired someone new and they did something in our environment that was different than we were used to, or we just may have been compromised, or something suspicious has occurred. That's where you want to get this down to. Once you whittle down your permissions to the point where you have a high level of confidence that the privilege of least privilege is being implemented to your satisfaction, now it's a monitor. Are these accounts and services being used the way we think they're being used? And if they're not, this is a deviation from what is normal, what a baseline normal read is, then do we have visibility into that and understanding what to do about it?
Yeah, that actually reminds me, it takes me back to a time with, I kind of cringe when I think about this, but take me back to, Serge mentioned like knowing what normal is in your environment. And what I'm not saying when I said that earlier, and probably what Serge is not saying as well, like, and I think that's where he was going with this, was like looking at your API calls that are done on a normal basis in your cloud logging or what have you, and then turning that into all of your allowed policies is not the best approach, because there could be something going on maliciously in that environment. And if you take that approach simply, you're allowing that malicious activity to happen in your environment. You basically allow listed that some kind of malice. So be careful with that. And the reason why that brings back bad memories is, it reminds me of a host intrusion detection solution vendor, which will remain nameless right now. They had like a learning mode where you could run this on your system, and it kind of looks at your system activity, like what executables are normally running, what DLLs are being referenced, what types of files are coming and going, what network activity is happening. So it's kind of monitoring the entire local system. And you could take what it learned and turn that into a policy and more or less say, if anything happens outside of this policy, knock it down. We've got a new executable trying to talk out over the network. That's not allowed. Let's stop that activity. So that's kind of a double-edged sword where neither edge is good, right? The one edge is, what if you didn't capture the legitimate traffic during that learning mode, just like in your cloud environment? What if you didn't capture an API call just because someone that does something once every 3 months, that didn't happen while you were investigating those logs, and you just lock them out from that capability, and then you have to tune your rules yet again. So it's a little more work after the fact. But the other edge of that is, what if you've allowed malice? Like, what if on the local system, like a Metasploit reverse shell had called out of that system while you're learning, which for those that aren't aware, just think of it as like a backdoor connection that's phoning home to attacker controlled infrastructure. Now they have control of that system. So if during learning mode that happened, you just allowed Metasploit, maybe not only on that system, but if you're applying that policy across all of your workstations, you've allowed Metasploit to be able to run on everything. And the same thing with cloud. Again, like if malicious activity happens, like data exfiltration, or a user's creating other users during this process, they have no business doing that, you've just created yourself a potential problem in the future at that point. I mean, you've probably already been compromised, but the compromise is only going to get worse or more frequent if you allow that activity to happen there. Let's see. After we make architecture application, what do we do? I saw that question pop in as well. That's actually going to tie into my demo, which I'm going to be bringing up right now. Actually, because this is a really awesome tool. I stumbled upon it just a few months back. It's called IAM Live. I'm actually going to share my screen here if I can figure out how to do it correctly. There we go. So in a moment, there we go. You see my screen. The tool is called IAM Live, and there's a link to it that I'll ask to be shared with you all as well. Free and open source, installs on multiple different platforms. But the idea behind this tool is it's performing what's called client-side monitoring. So if you're running, say, a cloud tool, like in my example, I'm going to be running the AWS CLI tools, command line interface tools, to talk to my cloud environment, as well as another tool, which I'll discuss here in a moment. But normally, all those requests are going to go directly to Amazon, right? Amazon servers across the globe. When I say, hey, Amazon, create an EC2 instance or a virtual machine for me, that I'm talking to an API endpoint. It's like ec2.amazonaws.com, for example. But with client-side monitoring, you could have a tool running on either your local system or another remote system that you can control. And over UDP port 31,000 by default, it will send that request there as well. That way you can see the interactions between the client, that are outgoing from the client, I should say, right? So that's what IAM Live is doing, but it's going a step beyond that. It's not just telling you, here's everything that you've requested with AWS. It's going to create a policy for you, right? Based upon what it sees. So if you only run a few instructions, that's all that's going to be in the policy. That could be very, very useful if, say, you want to deploy some application or you want to create some user that can do these specific actions. Test it out. Use IAM Live, capture that activity, and you'll have your policy pretty well created. Now, I say that with a grain of salt because in my mind, and maybe I'm just too critical, it's still not least privilege, but it is a huge step in the right direction. I'll explain what I mean by that momentarily here, but very easy to use. So you have to run this, if it's on a local system, in 2 different sessions. So that's why I have 2 terminals up here. And this is on a Linux, well, it's Windows subsystem for Linux, but just pretend I'm on a true Ubuntu system here, Linux system. So you just run the IAM Live with the set any command, and it just sits there and listens. That's all it does. It's listening on UDP port 31,000. Okay, so it's just going to sit there and do its thing. Now, in the other session, this is where you perform those activities. Okay, so there is some requirements though, because by default, at least with the AWS CLI, client-side monitoring is not enabled. So if I didn't run these commands, like setting up environment variables to say, I want to enable CSM, I want it to talk to this port, which is 31,000, and I want to talk to this host, which is my local host, it wouldn't send those commands. So that's why I have to export these environment variables. AWS CSM enabled equals true, AWS CSM port equals 31,000, and AWS CSM host equals 127.0.0.1. So now that that's in place, it should start talking whenever I issue commands via the AWS CLI or another tool that I'm going to bring up in a moment. So if you pay attention to the the right-hand side first, I'm going to issue the command AWS S3 LS and hit enter here. So what this is doing, well, we'll see what it's doing, right? We'll see what the request looks like and what the appropriate policy, if this is all my user was ever doing. Now, we probably don't have users that are just listing buckets, but this would be the policy for that user. So if I run that, you can see on the left-hand side, we've got the framework for an AWS policy. Let me explain really quickly the structure here. The magic happens in the statements, right? This is what the user can or cannot do. Like the effect is allow. So this is an allow rule or a series of allow rules here, right? And what's the action they're taking? This is the API call that was being performed by AWS S3 LS when I listed all of my S3 buckets that were part of my day job and course authorship and all that good stuff. But it's the S3 list all my buckets, right? Now, if I ran something like AWS EC2 describe instances, I want to see the instances in this account. Now I'm going to suppress the output because I've got some sensitive information as it relates to my instances here. But if I run that command, you'll see the policy changes a little bit. It's going to append another action. There it is. It's EC2 describe instances. So you can kind of see the power of this tool. Like as you're performing activities against AWS, you'll see a policy automatically being generated for you. And you can take this information, build a custom policy, and apply that to the affected user or group of users in that environment. I'm going to do one more thing here, just to not let this drag on too far. I just want to show you like a more complex behind the scenes thing happening that you can capture all of these actions. Because doing one command at a time is going to be tedious, and you have to account for everything that user is going to do. But let's just now assume that we don't have a user, but we have an application that's performing actions in our environment. The application in question is going to be Terraform. Terraform is an infrastructure as code tool, which can automate the deployment of systems, spin things up very, very rapidly. Like my Terraform deployment that you're going to see in a moment is going to set up a virtual private cloud, a VPC, a subnet, an internet gateway, a routing table, a network interface, a security group, a virtual machine, and I think that's it. So 8 resources being deployed in about less than a minute, I'll say. Like, to do all that manually would be an intense operation. I mean, it's probably still like a 20-minute job, but this is doing it in 1/20th of the time at this point. So there's a few commands I have to run here to initialize Terraform. So bear with the few second delay here. And you can see that just running like Terraform init to download the appropriate files for Terraform to do its job didn't talk to AWS because nothing is in the left-hand pane. So if I do Terraform plan, which that's more or less going to look at my configuration and determine what needs to be deployed in AWS, it's going to make some calls to that environment, right? So again, this takes a few seconds here to run, but as you see on the left-hand side, we've got some policies being created. Apparently, and I didn't know this until I ran it, Terraform was calling out to the EC2 service and describing account attributes as well as describing images. Because I'm going to be referencing an image, I know that one for a fact, I'm going to be referencing an image to say deploy an instance based on this Amazon machine image. So Terraform plan needed to perform that action. But now when I actually apply, right, I'm going to do the auto approve so this happens faster, you're going to see this policy is going to get much, much longer. Because if you remember, I'm deploying a VPC, a subnet, network interface, and so on and so forth. You can kind of just see it tacking on more and more and more permissions as we go here. So you see references to creating a VPC. You see a lot of describe, so a lot of read activity happening. So it's got to get information from AWS, this account, creating subnets, internet gateways, and so on and so forth. And it looks like it errored out for me. Let's see, is not supported. Interesting. So it looks like I was trying to deploy in US West to Delta, and that instance type was not supported. So go figure, right? The demo gods are mostly okay with me right now, but turns out I just picked Terraform on my behalf, picked an unsupported availability zone. But it doesn't matter. At the end of this, it would have deployed that instance. Everything else was deployed. So we will have captured all of the API calls for creating things. But since we're using infrastructure as code, it's got to destroy things too, right? Because infrastructure as code is very commonly used to rapidly deploy, rapidly tear down cloud infrastructure. So we also have to run one final command, and this should work. This should not error out, is destroy, right? Terraform destroy. Again, it takes a few seconds to like warm up and get a sense of what it needs to do. But as you'll see very shortly, we're going to have even more permissions being added to the policy on the left-hand side because it needs to destroy things. Because up to this point, it's been read, create, maybe update, but no delete yet. But now we're seeing detach, delete, so deleting VPCs, deleting subnets, and so on. And this was very fast because it didn't have to tear down an instance. So that is the one thing that would be missing from my particular policy. So if you're using infrastructure as code with this, make sure it actually succeeds. But assuming that you would also see things like terminate instance in here, because that's really the only other missing piece of this, you would take this policy and for whatever user account that this Terraform application is using in AWS, well, that would be a beautiful policy to start with. And I led into this saying it's a great start in the right direction. You're really restricting what this user can do, but it's not perfect. It's not perfect because of this resource reference here. Resource with a star in it means every resource that is in your AWS account, potentially, right? So what that means is I can delete not just the VPC that was created by Terraform, but all of them. So if an attacker gets a hold of these credentials, yeah, they're going to be pretty well restricted, but let's say they want to be very destructive. They can delete all of your VPCs. They can terminate all of your instances if that were to show up in there. They could delete your routing rules and really wreak havoc in your environment. So what I would do to improve this would be restricting which resources can be torn down in that environment. And that gets very tricky when you have dynamically created resources because you can't plan ahead, like what's this resource going to be called or things of that nature in some cases. So it gets quite tricky. But as I said, this is a huge step in the right direction because if, again, someone steals these credentials, they're very limited on what they can do. They can't impact your billing information. They can't access storage, for example. There are no S3 rules in here, for instance. So they can't access your sensitive information that might be in an S3 bucket, right? So that's more or less my demonstration here on this particular tool. Highly recommend it if you're in an AWS environment. And you might be asking, like, what's available in Azure? I don't know. There's no tool that I'm aware of that is capturing this information. I tried to do something myself, and Serge can appreciate this because he's our resident pen tester, does a lot of web app stuff too. I tried to capture Azure communication using Burp, and maybe I could see the permissions that were being requested or what those API calls were. And it did not match one-to-one with what those permissions are called in Azure with what I'm seeing on the wire. So I'm sure someone could write a tool if they could do all those, tens of thousands of translations, but I don't got time for that. So that's kind of where I stopped with it. All right. So anything you all would like to add to that discussion or anything, right? I've seen some comments popping in, but I'll also open it up to anyone listening. Any last minute questions? We are approaching the end of our hour here that you'd like to hear about. Least privilege, as you can tell, we can talk forever and ever and ever. So I'll first open it up to Simon and Serge, and then we'll address any questions that we see pop in last minute here.
Well, I'd just like to say I've seen that tool. You mentioned it to me the other day. I did have a quick look at it in the background before we started today. But one of the use cases for it I immediately jumped to was, and I spent 3 months trying to help a developer company out trying to solve their IAM problem, which this tool would have helped hugely to facilitate that. What I would have used this for would be to diff my policies. So I would create my policies, create them from the default policies, set them up, tweak them so that my own, and then I would diff them against what this tool discovered. Because then I can identify what's being used, what's not, what can I remove, what other things can I get rid of out of my own custom policies. But yeah, awesome demo otherwise. And some, a couple of great questions come in as well during that last session.
Thank you, Simon.
Yeah, right on. I think we should just answer any questions I see popping up here, and I don't really have anything else to add for that. You guys covered it really, really well.
All right. Yeah, I didn't really see anything else pop in either since I think we covered everything up to this point. So again, I'll leave it open for like another minute or so if anyone has any comments. But while we more or less thank you all for being here, and I hope to see you at a SANS event. I'm not here to sell you things or anything like that, but if you were to attend a class, I mean, we all teach Sec 488. It's a very essential class, no pun intended. I mean, it is titled Cloud Security Essentials after all, but it's just a little bit of description of the course itself. We do cover many facets, including least privilege. We have an entire day, in fact, talking about identity and access management, IAM. So lots of things on users, groups, roles, permission sets, multi-factor, how you can share access from into your own account, and so on and so forth. And we try to cover as much cloud security as possible in that 5 days of lecture. We round out the day putting your skills to practice with a Cloud Wars, which is really cool, very similar to Net Wars if you've taken that before. So hope to see you there, or at the very least, hope to see you at a SANS or non-SANS event in the near future. So that's all I have, other than some questions that we'll be answering here in a moment.
Yep, I would just wrap it up myself and say thanks to you all for joining. Really appreciate that. Thanks to you for making the time to be here with us today. You got lots of choices what to do with your time. Hopefully you got a lot of value out of this, had some fun, learned a few different things. Go check out that IAM Live tool. Definitely recommend that. And, see where your career path and exploration takes you. Hopefully we do get to see you live, in person, or virtual, as the case may be in the future.
Yeah, absolutely. It's been a good session today, and there's actually some really sort of good questions that have come through. There's one or two that popped on the screen now. I think probably more targeted towards Serge's area of expertise as well. But I'd just like to say, I hope you enjoyed it. The best way for you to experience some of this, especially if you've never jumped into the cloud before, is get yourself a free account. Both AWS and Azure give you them. Get a month's worth of credits from either of them, or run micro instances in AWS. You can run all sorts of things out of the environments. Just have a play. Don't put anything sensitive in there, but just have a play, experience it. You'll soon learn how the API and the HTTPS side of everything work, the web-based control side, and it's not long before you'll be diving into Terraform code and swearing at Azure like everybody does.
There you go.
All right, so we do have two questions from Andrew, which, as Simon mentioned, is probably more in Serge's line of work. He actively practices this, but what are common attack vectors for AWS? Which I'll just describe one of them, and then I'll let Serge extend upon that and also answer how can you attack EC2 by burp, by what method? So burp, of course, being a web interception proxy, and you can play around with web traffic and all that stuff. But again, Serge is much more well-versed in that tool than I am. So common attack vectors for AWS, I hate using this. It depends, right? If you have web services running that happen to be hosted by AWS, well, that could be an attack vector, right? Just like a web server hosted anywhere. But there's also some specific attack vectors that are present, again, not just in AWS, but in cloud in general. There's a service called IMDS. I'm not going to go down crazy down the rabbit hole here, but it's the instance metadata service, which when you apply a role, for instance, to your AWS system, IMDS is what is used by the locally installed tools to retrieve those credentials, to be able to interface with the AWS environment using those permissions that we've assigned to that role, right? So that's an attack vector, because if I own that system, right, for lack of a better term, or if I find my way on that system and I'm able to query that IMDS service, which is trivial to do, by the way, I can acquire AWS credentials and extend my reach into the cloud environment and access anything that system has access to, or I should say the role that's tied to that system has access to. Now that there's a lot of assumptions here. Like I have to establish that presence. So I have to compromise that system in some way. There's also web-based attack vectors, which I'll leave up to Serge to mention here. One that comes to mind, of course, is server-side request forgeries. But again, we're getting more into Serge's area of expertise. So I'll let Serge wrap up that question.
Right on. Thanks for that. And great questions, by the way. Much appreciated. So just to add on a little bit to what Ryan said, what we see here in the cloud is IAM being the new perimeter, and not just cloud, but really in cybersecurity in general. The new perimeter. What does that mean? It used to mean you have external attack surface, and that was the quote unquote perimeter. Nowadays, we're talking about identity and access management as being the fortified entry point into your world, cloud world. So the main thing there is going to, in addition to what we've already heard about, would be locking down IAM. That's the big thing. If someone can get access to a cloud-based account, that's going to be significantly detrimental to your ability to secure your environment. Now, the second half of that is going to be the question as pertains to attacking EC2 instance with burp. EC2, VM, and Azure, doesn't matter if it's on-prem, doesn't matter if it's sitting in your house. It's all relevant. It's all the exact same in essence, because you're targeting the layer 7 application that's running on that instance. And that's, as long as the security groups allow, port 443 and port 80, everything else is pretty similar until you get onto the machine itself. All right, so we're talking application layer attacks, and that's OWASP top 10. The new top 10 list does include server-side request forgery. If you're not familiar with OWASP and the OWASP top 10, you're gonna have to Google that since we're getting really low on time right now. OWASP top 10. There's a list that'll come up in 2021, which is the newest list, and I'll talk through all the different application layer attacks. If you're going to specifically target an EC2 instance or web application running in the cloud, though, using burp, you said what method would you use? You're using tools like Intruder, using tools like Repeater, which is all built into Burp Suite, by the way. What you want to do is basically ascertain what attack surface resides on that instance. We're talking input boxes, we're talking anywhere you can potentially inject code or maliciousness, and see how the application responds, whether, like I said, it's EC2 or VM and Azure, or as the case may be. Basically make a request with some malicious content and see what the response comes back as, whether it's a 500 response code or 200 or 401 or whatever it happens to be, and take it from there. And then use Burp Professional if you have it, or the Z-Attack proxy, which is Zap, free open source, very, very similar to Burp, to ascertain what weaknesses may or may not be there, and then take it the next step if you can. Really, really long-winded, high-level answer, because we don't have too much time to delve into it more than that. Hopefully that adds some value to you, though.
Yeah, Serge just gave you a free Sec 542 lesson in like 2 minutes. Awesome. All right, well, I think that's all we got. I think Serge answered the last question anyway during that little ramble there. So that's good stuff. So again, hope to see you all around. Maybe at a SANS event, maybe not, maybe outside of that. But hope you enjoyed the session. Plan on having many more of these with different topics. So if you have any suggestions for topics, please throw them in the comments as well, and we'll consider those, because obviously if the community wants to learn more about them, we need to provide that here at SANS. So thank you everyone for attending.
Thanks everybody.
Thanks. Bye-bye.